Hello and good afternoon. Welcome to another geometry lesson. We are in section 10-5. Today we're going to be using trigonometry to find area. So what I'd like for you to be able to do is to use trigonometric ratios to help you find the area of polygons today. But it's been a while since we've talked about trigonometry, so let's review that. In example 1, we have a quick review. So we have three trig functions, sine, cosine, and tangent, and they are going to relate two sides of a triangle to one another. And in particular, we can only do this with right triangles. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So wherever our angle is, so like if we're at angle A, where is opposite from A? Well, 6 is opposite, 8 is adjacent, and 10 is the hypotenuse. We're going to use those definitions of what sine, cosine, and tangent are to find those ratios for angle A in this first one. It says, what is the sine, cosine, and tangent of angle A? I'm going to write out that little acronym that we had that helped us, and it was SO, CA, and then TOA. So S stands for sine, O for opposite, and H for hypotenuse. So sine is opposite over hypotenuse. C stands for cosine, A stands for adjacent, H stands for hypotenuse, so that is cosine is adjacent over hypotenuse. T is tangent, O is opposite, A is adjacent, so tangent is opposite over adjacent. So let's find the sine, cosine, and tangent of each of these. So I'm just going to write sine of A, cosine of A, and then tangent of A as well. Sine is opposite over hypotenuse. So here's the A. What side is opposite from the A? So on the other side of the triangle is the 6. 6 is considered opposite. So it's going to be 6 over, and then hypotenuse. Well, the 10 is the longest side. It's the hypotenuse, so the sine is 6 over 10 of A. Cosine is adjacent over hypotenuse. So the cosine of A, here's A, what side is adjacent? The 8 is adjacent. We can't say 10 is the adjacent side because 10 has to be the hypotenuse. So 8 is the adjacent side and 10 is the hypotenuse. So we have 8 over 10. And then finally, tangent is equal to opposite over adjacent. So here's my angle A. Opposite side from A is the 6. The adjacent side to A is 8. So we have 6 over 8 for that one. And we're just leaving it like that. Now we want to find the sine, cosine, and tangent of angle B. So angle B is right here. We want to find the sine of B, the cosine of B, and the tangent of B. So here's B. What is the opposite side from B? Because sine is opposite over hypotenuse. Opposite of B is 8, while the hypotenuse is still 10. So I have 8 over 10 for the sine here. Now I'm doing cosine. Cosine is adjacent over hypotenuse. So here's my angle B. What side is closest to it? Well, that's the 6. That's the adjacent side. Hypotenuse is still 10, so I have 6 over 10. And finally, I'm doing tangent of B. Tangent is opposite over adjacent, or 8 over 6. So that's just a quick review. We covered that stuff in chapter 8, I believe it was, which was all about triangles and trigonometry and right triangles. So this is just to review sine, cosine, and tangent. We're going to need to use this to solve for some of our next examples. So in example 2, it says find the area of the regular octagon. Because we're finding area of a regular shape, we know we're going to need to use the formula area is equal to 1/2 apothem times perimeter. Well, we do not know the apothem, And we don't know the perimeter either, but we can easily find the perimeter rather quickly because we know if one side is 18 and they're all the same size, then I can just take 18 times how many sides there are. So 1, 2, 3, 4, 5, 6, 7, 8. 18 times 8 is what the perimeter will be. So I'll just do that over here to the side. Perimeter is equal to 18 times 8. And when we take 18 times 8 and we put that into our calculator, we are going to get 144, I believe, but let me check it one more time. Yes, 144. So the perimeter is equal to 144 now. But now we need to figure out how long the apothem is. So to do that, I'm going to put my center of my shape in, and I'm going to draw in an apothem. Put in my 90-degree angle, and then I'm also going to draw in a radius. And what I'm going to do, I'm going to focus in on this right triangle, and if I can figure out enough information about it, then I can use trig to figure out the apothem. So right off the bat, if the whole distance is 18 and the apothem cuts that side in half, half of that distance is going to be 9. So I now know that bottom side is 9. I need to figure out the value of an angle in this. Well, to find the value of an angle, let's remind ourselves of what happens if I draw in all these radii real fast. Whoops. I'll just do a couple of them. So notice this angle and this angle and this angle are all the same size, and it would continue to do that all the way around. To figure out the total angle from there to there, I'm going to take 360, or a full circle, and divide it by how many sides there are. So I'm taking, this is some side work, I'm taking 360 divided by 8, and that's going to get me 45 degrees. The 45 degrees is all of that. I only want to know half of it though. So I'm just going to get rid of some of this extra stuff because that was just so you could see what I was doing. If the whole value of that angle measure from here to here is 45, but I only want to know that small section of it right there, I'm going to take 45 and divide it by 2. So I have 45 divided by 2, which is 22.5. So now I know quite a bit about this triangle. I know it's a right triangle, and I'm just trying to calculate the apothem. So with what we've got so far, I'm going to take this triangle, pull it down to the side just so you can see it a little bit bigger and clearer. I'm just redrawing it so it's larger for you. So here's my 90-degree angle. I don't know how long the apothem is. I know that angle right there is 22.5, and I know that this side is 9. We are going to have to use trigonometry to solve for how long A is. I can't use the Pythagorean theorem because I don't have two sides, and I can't use special right triangles because this is not a special right triangle. So I'm going to have to use trig. Here is my angle, the 22.5. What are the two sides that I know in relation to that 22.5? Well, 9 is the opposite, so I'm going to say, I'm just going to label that right here just so you can see it. 9 is opposite. And the A is the adjacent side. So which one of our trig functions uses opposite and adjacent? If you need to come up and refer to your SOHCAHTOA, you can. So sine uses hypotenuse. Cosine uses hypotenuse too. Tangent uses opposite and adjacent. So I now know I'm going to use tangent. So I'm going to say the tangent of 22.5 is equal to opposite 9 over adjacent A. I'm going to put that tangent of 22.5 over 1 so we can just quickly cross multiply and make that a little bit simpler for us. So when I cross multiply, 1 times 9 is just 9. And then A times the tangent of 22.5 is A tangent 22.5. The tangent of 22.5 cannot be separated. It's all one unit. But I need to get this a alone. This means a times the tangent of 22.5. So I'm going to divide by the tangent of 22.5 on either side. And now I'm ready to put that into my calculator. So what I'm typing into my calculator is this. Hold on, let me write it out again. 9 over the tangent of 22.5. Okay, I am going to type into my calculator now. First of all, we got to turn it on, and I'll clear this stuff out. We want to make sure that it's set to degree mode because that's what we're working with. And I'm going to say 9 divided by, now I'm going to hit my tangent key, and I'm going to put my value of the degree in there, 22.5, close the parenthesis, and I'm getting about 21.7. We'll round to the nearest tenth. That'll be fine. So now I know the apothem, or that side of that triangle, is 21.7 long. So I'm just going to put that up here into my values for my formula. Now I know the apothem and the perimeter. I'm able to go straight into that formula now. So let's do that. Area is equal to 1/2 times 21.7 times 144. Definitely going to need your calculator for that. And when I type all that in, I am getting 1,562.4. And I'll just say feet or square feet. So the only new part, and it's really just trying to pull way back from our memory from chapter 8, is now instead of only special right triangles, we could also use trigonometry to find a missing side length on a triangle. All right, we're going to do one more example, and then that'll be all for today. So this one says, what is the area of a regular pentagon with 4-inch sides? Round your answer to the nearest square inch. All righty. First, I'm going to draw a pentagon because that's going to really help us visualize what's going on. I'm going to do my best to make it at least a little regular. There we go. There's my pentagon. And it says it has 4-inch sides, so I'm going to label this as 4 inches right here. And then I'm going to put in a center, and it's just asking for the area. So I know that I need to use the area 1/2 apothem times perimeter. I don't know the apothem, I don't know the perimeter, but I can figure both of them out. So I'm going to draw in my apothem real fast and label it as A, so we know that's what that is. And remember, this is a regular pentagon. So if one side is 4, and I'm trying to figure out the perimeter, that's 4 plus 4 plus 4 plus 4 plus 4, or 4 times 5, which is 20. So the perimeter is 20. That part was easy. Now we need to figure out the apothem. So I'm going to draw in a right triangle. And we are going to focus in on this right triangle right here to help us figure out how tall the apothem is. But what I want you to know is, because all the sides are the same length, if this side is 4, then this whole side down here is 4, which means half of it would be 2. So I'm going to say from here to here is 2. Now I need to figure out what this angle right there is. To figure out that central angle, I am going to take 360 and divide it by how many sides there are, which is 5. When I take 360 and divide it by 5, I get 72. Okay, 72 is not that angle, it's actually double that angle. So I'm going to take 72 divided by 2 now, and that's going to get me 36. All right. So at this point, I know that this angle in this triangle is 36 degrees and it's a right triangle. I'm going to draw that a little bit bigger just so we can see it. And we know what we're talking about. So this side's 2. We don't know the A. And this one is 36 degrees. Okay. We're trying to figure out the A, or the apothem. If we need to write out SOHCAHTOA up here, then we can. Because we need to figure out what function are we going to use. Are we going to use sine? Are we going to use cosine? Or are we going to use tangent? Okay. The 2 is opposite from the 36, while the A is adjacent to the 36. So we're going to use tangent again on this problem. So I'm going to say the tangent of 36 degrees is equal to opposite 2 over adjacent A. Now I'm able to just cross multiply. And that gets me A times the tangent of 36 is equal to 2. I need to get this A alone. And remember, tangent 36 is a fancy way of writing a number. If you typed tangent 36 into your calculator, it would get you a decimal. And that's all this is representing. But it's an easier way to write that decimal so we don't have to round or anything like that. So I'm going to divide by the tangent of 36 on either side. And now my apothem is going to equal 2 divided by the tangent of 36. I'll show you how to do that into your calculator. So we've got our calculator. It's set in 2 degrees. So I'm going to type 2 and then hit my division key, then my tangent key, input my angle value, and then hit equals. And that's getting me about 2.8. I'm going to round to the nearest tenth. So 2.8 because the 5 makes the 7 round up. So the apothem is approximately 2.8. Let's stick that into our calculator, into our A spot. Now we're going to substitute all that into our formula. So area is equal to 1/2 times 2.8 times 20. And when I do all that, I'm getting the area is equal to 28 units squared. And there's our solution. That's all for this video. I hope you have a wonderful evening.